Hello students, you're welcome to this calculation in chemistry series. In today's class, we'll be talking about empirical and molecular formula. We'll look at some exam questions. Now, what is the empirical formula? The empirical formula is known as the simplest formula. It is simply defined as the simplest formula of a compound. The empirical formula doesn't give much information about a compound. For example, let's say you have benzene. Now, the empirical formula of benzene is CH, while the structural formula is C6H6. If you look at this, the empirical formula just tells you that benzene has carbon and hydrogen. It doesn't give you the actual number of carbon and hydrogen. The molecular formula, on the other hand, tells you that benzene has 6 carbon and 6 hydrogen. So it gives you more information about benzene, okay, than the empirical formula. Now let's see how to determine the empirical formula of a compound. If you're given a question and you're asked to determine the empirical formula, it's very easy. You just follow 2 steps. I'm going to illustrate these steps using some of these examples. Now, number 1. Question 1 says, a hydrocarbon contains 85.7% carbon, 14.3% hydrogen by mass. Determine its empirical formula. Now, this percentage you are given is the percentage composition of carbon and hydrogen in the hydrocarbon. So to solve that, we're going to write out the symbols of the elements first. Now, to solve that, like I said, it just has 2 steps, 2 simple steps. The first step to take, let's write out the percentage composition. Now, the first step to take is you need to divide each of the percentage you are given by their atomic mass. So we say divide by their atomic mass. So the atomic mass of carbon is 12. Y for hydrogen is 1. So if you divide this, 85.7 divided by 12, that will give you 7.141. 14.3 divided by 1 is 14.3. Now, the second step to take, which is the last step, is you look at these 2 values you got after dividing. Okay, which of them is lower? All right, you can see 7.141. So you divide by 7.141. You divide both of them by 7.141. Okay, so when you divide the both of them, this will give you 1, this will give you 2. Therefore, our empirical formula is C1. We don't write 1 in chemistry, so I'm going to omit the 1, and H2. As easy as that. That is the empirical formula. Let's take a look at another question. A compound contains 40% carbon, 6.7% hydrogen, 53.3% oxygen. If the molar mass of the compound is 180 grams, find the molecular formula. In this question, you would see that aside from the percentage composition, okay, we were given molar mass of the compound. Now, this is a hint that we are going to find the molecular formula. So how do we do that? To find the molecular formula, the first thing you need to do is you look for the empirical formula of the compound, then you use the empirical formula which you got to get the molecular formula. So now let's start solving this question. So from here, we have carbon, we have hydrogen, we have oxygen. The percentage of carbon is 40, hydrogen is 6.7, oxygen is 53.3. So the first step, like I told you, is you divide by the atomic mass of each of the elements. All right, so when you do 40 divided by 12, let's use our calculator, you're going to get 3.3333. So I'm going to just use 2 decimal places. 6.7 divided by 1 is 6.7. 53.3 divided by 16, that will give you 3.33. So I'm going to use 2 decimal places. Now, you look at the value, look at each of the value, which of them is the lowest. We have 3.33, so you divide each and every one of them by 3.33, which is the lowest value. So divide this will give you 1, this will give you 2, this will give you 1. So our empirical formula EF becomes C1, we don't write 1 in chemistry, H2 and O1. Now, having gotten the empirical formula, you use it to get the molecular formula. Now, there is this equation which I'm going to write. So it is empirical formula in brackets N is equals to the molar mass you were given, which is 180. So the empirical formula is CH2O in brackets N equals to 180 gram. So for this empirical formula, you substitute in the atomic mass of each of these elements. So carbon is 12, oxygen is 1, so we have 2, hydrogen, sorry, is 1. We have 2 hydrogen there, so it's going to be 2 times 1, which is 2, plus the oxygen is 16. All in brackets N equals to 180. If you sum this up, you are going to get 30, then N equals to 180. Alright, so divide here by 30, divide here by 30. So literally, we are trying to get the value of N. So divide here, your N becomes equals to 6. Alright, scroll up a bit. Now, from here, having gotten this value of N, take this value of N, substitute it into this place. Okay, our N now is 6. So we have CH2O in brackets 6. Okay, so from here, you now say, okay, you expand, just you do something like expansion. So this is 1, remember, there is 1 there, although we didn't write the 1 there. There is 1 here, there is also 1 here. So from here, this becomes 1 times 6, that's C6. 2 times 6, 12, so we have H12. And 1 times 6 for the oxygen, that's 6. So this is your molecular formula. Let's take a look at one more question. Alright, for this question, it says a hydrocarbon has an empirical formula CH and a vapor density of 39. Determine its molecular formula. We're already given the empirical formula from this question, and we're told that the empirical formula is CH. Remember, I told you, before you get the molecular formula, you firstly need to get the empirical formula. But they've done that work for us, so our work is easier. So to get the molecular formula, remember the equation I gave you, I said the empirical formula EF in brackets N is equals to the molar mass. But in this question, we're not given the molar mass, but we're given the vapor density. Now, there's a relationship between molar mass and vapor density. I talked about it in one of our videos in this series, where we talked about calculation of molar mass, relative molecular mass. Now, the relationship between them is that the molar mass is equals to 2 times the vapor density. So the vapor density you are given, you must just multiply it by 2. So we have 2 times 39. So 2 times 39, 2 times 9 is 18, write down 8. 2 times 9 is 18, write down 8, you carry 1. 2 times 3 is 6, so you have 78. So from here, our molar mass is 78. Okay, so from here, the empirical formula, which is CH, all in brackets N, is equals to 78. So from here, we have, you insert the atomic mass of each of the elements. Carbon is 12, hydrogen is 1, all in brackets N is equals to 78. So this is 13, N is equals to 78. So divide here by 13, divide here by 13 to get the value of N. So 78 divided by 13, that will give us 6. So we have N is equals to 6. So from here, take this value of 6 and put it here. Okay, substitute N as 6. So we have CH, all in brackets 6. Remember, there's a 1 here, there's a 1 here. So you expand. So it becomes C6 and H6. That is your molecular formula, which is option D. Alright, so there you have it, students. So I believe with this video you have now learned how to determine the empirical formula and molecular formula of a compound. All right. So please, if you have a question, okay, which maybe in the event of you learning and is giving you issue, please bring it. Send it to the comment section and I will be there to assist you. So please don't forget to like, share and subscribe. Thank you for watching.